Okay, so part two, the balancing equation um, in acid solution or in basic solution. Um, okay. Okay, so let's take a look at this problem. This reaction, you have to balance the equation of dioxyvanadium 5 ion with zinc in acid solution. Okay, so now if the reaction is an acid solution, you can either add H plus or water. Usually water is a source of oxygen and hydrogen. H plus is a source of the hydrogen. So now let's take a look at this example. We will use the half reaction method again. We're going to start with something simple like zinc, and then zinc becomes zinc 2 positive. Now you can see that the mass is balanced, but the charge is not. So you have to add 2 electrons on the right side so the charge is balanced. You can see the zinc its oxidation number increases from 0 to 2 positive. So that means zinc is being oxidized. So that means itself is a reducing agent. And then this reaction, because electron is on the product side, so this is the oxidation reaction. Okay. Now let's take a look at vanadium, VO2 positive. Okay, and then it becomes VO2 positive. Vanadium is balanced oxygen. There's 2 on this side, there's 1 on this side. As I told you, the source of oxygen in acid solution is water. So you need 1 oxygen on this side, you add 1 water. Per each 1 water gives you 1 oxygen. So now the vanadium is balanced, oxygen is balanced, but this side is 2 hydrogens. The source of the hydrogen is H plus. You need 2, give it 2. So now everything is balanced, vanadium, and then 2 oxygens, okay, and then 2 hydrogens, but the charge is not balanced. The net charge on this side is 3 positive. The net charge is 2 positive. So you have to give 1 electron over here. And now if you can see that because the electron is on the left side, this reaction is a reduction. Okay, reaction. And vanadium, if you look at it closely, you can see that its oxidation number is positive 1 on the total. Vanadium is X, oxygen is 4, a negative 4. So vanadium is positive 5. So positive 5 over here. And then over here, it becomes 2 and then minus 2x. So x is equal to 4. So oxidation vanadium is 4 positive. So its oxidation number actually decreased. So that means that it is being reduced. Who's reducing it is zinc. So itself here, this has to be an oxidizing agent. Okay. Now, if you want to add the 2 equations together, you there is a slight problem because the number of electron doesn't balance out. There's 2 over here and there's 1 over here. So you have to multiply the second equation by 2. So now let's bring down the zinc. So we have zinc over here, and then bring this down. Electron and electron canceled out because you multiply by 2, but you will have 2 VO2 positive, and then you have 4 H plus, and then you have zinc ion, and then you have 2 VO2 plus, and then 2 water. Okay, so now let's check. You have zinc, 1 zinc, 2 vanadium, and then you have 4 oxygens, two over here, two over here. Okay, four oxygen, four hydrogens, four hydrogens. Net charge on this side is equal to 6. Net charge on this side is also equal to 6, so equation is balanced. Okay, so next one is permanganate and iron. Okay, so what we'll do is we're going to look at the simple one first, Fe2 positive, and becomes Fe3 positive. We'll add one electron over here, so mass and charge is balanced. So you have permanganate, okay, and then becomes Mn2 plus oxygen, 4 oxygen over here, so you have to add 4 water. Each water gives you 1 oxygen. So you have 8 hydrogens over here. You have none on this side. So you will add 8 H plus. Okay. So the mass is balanced, the charge is not. You have the total net charge on this side is 7 positive, 2 positive. So you have to add 5 electrons. So that the net charge on this side is just like the other side. 5, negative 6 plus 8, so 2 positive. So you cannot add the two equations. You have to multiply this by 5. Okay, so the 5 electrons can cancel out. Add the two equations together. You have 5 Fe, 2 positive, and then you have MnO4. Okay, and then you have 8 H plus, and then this would give rise to Fe3 plus, and then 5 Mn2 plus, and then 4 water. Okay, so now let's check. You have 5 Fe, 5 Fe, and then you have 1 Mn. Oh, sorry, this one you erase this. Okay, so one manganese on each side, 4 oxygens. Okay, 4 oxygens, and then 8 hydrogens. 8 hydrogens. Let's check the charge on this side. This is you have total of 10 positive, 18 positive, minus 1, 17 positive. And then over here, you have 15 plus 2, 17 positive also. This one is because the electron is on the right side. This is oxidation reaction. Because the electron is on this side, this is reduction reaction. Okay. Fe, because it is oxidation reduction reaction, so that means it is a reducing agent, and then this permanganate is an oxidizing agent. Okay, I'm gonna stop right here.